talking about independent events. Okay, so what are independent events? The independent events, like in just a word explanation, is just no effect on each other. Okay, no effect by the previous events, or like this event's got no influence on this one. Whether this happened or not doesn't influence the probability of the next thing happened. Okay, this is called an independent events. Well, have a think about independent events. Say, like say Jack wear what color, like the red or black clothes, doesn't influence like Lily wear what tomorrow. Okay, so this is no connection between each other. So those two events will be independent events. Like what you wear is independent from what I wear. Your wear, like whether uniform or casual clothes, doesn't influence on what I will wear tomorrow. So these called independent events. So a more implicit explanation will be the event B happened. We know that event B already happened. That doesn't change the probability of A happens. Okay, so this is this formula here. Like that's all word explanation, but you can't always see whether they're independent or not by the wording. So we use formula to test it because we are learning math. Okay, so that is the formula. So this formula is just exactly like what I was explaining for independent. So the events, I know that event B already happened, but that doesn't change the probability of A. So given you B happened, then you find probability A. That would be the same as directly find probability A, which means there's no connections between each other. Okay, no connections between each other. Okay, phone away please. Have your notes out. Okay, and this is the formula by directly explain it. Okay, directly explain it. So the happens of events B doesn't affect the probability of A. So this is the first formula we can use. Okay, that's the most explicit explanation for independent events. And then if we doing something more for this question, let's have a think about what's probability A given B. Probability A given B is probability A intersects B and divide by probability B. Okay, divide by probability B. So your left hand side can be expressed in that. Okay, your left hand side, according to the given formula, I can have that thing in the box. And then that equals to the right hand side. Okay, so that's just expansion form for left hand side, and that's still equivalent to the right hand side. So those two equals to each other. If you times both sides by probability B, what you will achieve? You will achieve that one. Probability A intersects B equals to probability A times probability B. Just times the probability B to the other side, times the denominator, and then you have that equation. So that's just transfer from that. Okay, it's exactly from the same equation, but looks like a little bit different. So it's probability A intersects B equals to probability A times probability B. That's the second equation. Okay, that's the second equation for independent events. Well, if it is they are independent events, it will satisfy both A and B, because A and B are basically talking about the same thing. Okay, it's talking about the same thing. But number 2 is commonly used. Okay, number 2 is the most common one we check it. If like the first time you mention independent events, the first thing I will think about is the second formula. Okay, it's the second formula. Because in year 11, year 12, we use that more. Every time when the question says that's an independent event, you will say probability A intersects B, that's A times B. Okay, so instead of using the first one. But first one is still correct. Okay, it's nothing wrong with the first one. It's also correct. But the second one is like commonly used for year 11, year 12 students. Very, very important for the second one. But the second one comes from the first one. Okay, second one comes from the first one. First one is by the explicit wording explanation, we can write out that equation. And by expanding and like rearranging, we have number 2. So therefore, 2 is the same as 1, but 2 is commonly used. And there's 2 lines below here. For multiple events with selections made by with replacement, events are independent. So what does this thing means, you have a box of chocolate. It's like some wipe as red, some wipe as green. So red and green, you select one, okay, and then you put that back, and you select the second one. Your first selection and second selection are independent if you put the thing back. Because what you have select for the first time doesn't affect the total, doesn't affect the colors at all. So you will have first and second selection are independent. But multiple events with selection without replacement is not independent. Okay, it's not independent. Why they are not? If you select the first one, okay, if it's a red, your red decrease by 1 and total decrease by 1. But if you select a green one, it's the green reduced by 1, the red remain the same, and the probability will be totally different, okay, according to what you have select for the first time. The tree diagram, think about the tree diagram, the two events, like for next selection, that is different. So that is a dependent event, they're not independent. Okay, it depends on the first selection, you will decide your second selection's probability. Okay, so it is different for without replacement. So it's not independent for without replacement. Okay, let's just have a look at examples. And I'll show you one example which is really important. I can't find it. I think it's a textbook question. I forgot whether it's a year 10 textbook or year 11. I think it's a year 10 textbook questions. I'll show you a similar question. Okay, and it's very important. Well, I can show you actually now. I'll give you, say, probability A union B equals to 0.9, and probability of A that equals to let's say that's a 0.8 and that's a 0.2. Hopefully that will work. Maybe not, but it's okay. And then I will say A and B are independent. And I want to find probability of B and probability A intersects B. Okay, that's everything you have. Have a think about what you could do to that question. You need to use the union additional rule. Okay, you need to use the additional rule because it's a union question. You need to use the additional rule and you need to use the independent. Okay. Okay, I'll give you a couple of minutes to think about. Well, the number may not be very nice because I made up this question. That is the method. Okay, what method you use. anyone can actually get the answer? Yes, yes. P.06. No. I think what you think is mutually exclusive. That's 0.6. But they are independent. Okay, let's do it together. I said you just need to use two formula, okay? One formula, when you see A union B and A and B, that must be an additional rule and intersections, okay? So that is probability A union B equals to prob A plus prob B. Subtract prob A intersects B. Okay, because they are independent, then this one is prob A times prob B. Okay, they are independent. So intersection A intersects B must be A times B, right? It must be that. So therefore, I can put the numbers in. That's 0.8 equals to 0.2 plus like prob B, I don't know. I just say prob B is X minus A times prob B is 0.2X. Can you solve for it? Is that very easy to solve? If you can't see prob B as a number, then just put prob B as X, like prob B equals to X. Okay, so prob B equals to X, then what you have is just a linear equation to solve. That's 0.6 equals to 0.8x, x equals to 6 over 8, which is 0.75. That's prob B, okay, that's prob B. Prob B is 0.75. And prob A intersects B will equals to 0.2 times 0.75 because it's A times B, because independence. Okay, it's A times B, same as here. So 0.2 times that, 0.15. Okay, 0.15. I think a lot of you already come to like this step. Instead of X, you write prob B, and then you can't see it, and then you can't solve for it. Okay, a lot of you have reached that step already. So remember, that's just a number. When in one equation, you only have one thing you don't know, and that's an equation you definitely can solve for it. Okay, it doesn't matter if it's a quadratic or a cubic or a linear. If you just have one variable, like one thing you don't know, they look all the same everywhere in your equation, then you can solve for it. If you can't see, put in an X, like put that thing in an X, then you can see it. All right, questions? No question? Okay, give you 1 minute to finish up the writing. It's a really good question. Okay, it's not hard. It's just a combination of exercise C and exercise G. So it's just a combination of that. Okay, let's have a look at example 1. Example 1 will be easier. Okay. So a selection of 10 mobile phone offers include 4 free connections and 5 with a 3-second battery, while one offer has both free connections and a 3-second battery. Let A be the event of choosing a mobile phone with free connections. B is the event of choosing a mobile phone with a 3-second battery, and summarize the information in a Venn diagram. Okay, I'll just give you 30 seconds to complete this Venn diagram. Okay, if you don't have that, then that's wrong. You must have the 2 outside. Okay, if you don't have that 2, you will definitely lose 1 mark in your test. Okay, you will be asked to sketch Venn diagram. You have 4 free connections and 5 free batteries, in total 8, because 1 in common. And then the outside must be 2, because it's 10 selections. Okay, probability A. What's the probability of A? Yeah, clear? How do you work? So it's 4 over 10, 0.4, yep. What's the probability of A given B? Okay, if you use the given one, it's the number of A intersects B over the number of B. Okay, remember the equation for given questions? Okay, given is intersection divided by the back one. So intersection is 1. Probability of B is 5. It's 5. Number of B is 5. So it's 1 on 5, which is 0.2. State whether or not events A and B are independent. Okay, if they are independent, probability A must be equivalent to probability A given B. So because probability A given B is not equivalent to probability A, so A and B are not independent. Okay, A and B are not independent. If they are independent, you must see that A given B is same as A. Okay, that's by using the first formula to see whether they are independent or not. Because I already have A given B and A, it's not necessary for me to find intersections and then A and then B. Like, it's easier to use the first formula. Then let's see the second one. A selection of 6 different baby strollers, including 3 with free ring cover and 4 with a free sunshade, and 2 offers both. Okay, let A be the stroller with a free sunshade and B is with a free ring cover, and give you 30 seconds to sketch the Venn diagram again. When you finish, just have a look at the answer. Be aware A and B. Okay, A is the sunshade, B is the ring cover. Okay?
Question that you gave us.
Which one? Oh, yeah?
I'm a bit confused on one of the lines where 0.6 equals something.
This part?
Oh, okay, I just want to check a little bit better.
Okay. Do you have the same thing here? Okay, then what's probability of A? 4 out of 6, that's 2/3. What's the probability of B? Yeah, half. Okay, what's the probability A intersects B? So it's 2, in the middle is 2 over 6, that's 1/3. Okay, state whether or not they are independent. Okay, you have probability A, you have probability B, you have probability A intersects B. You have the three components that you need to test them. So the way I will write it is I want to find what's the probability of A times B. Is 2/3 times a half that equals to a third. Therefore, probability A intersects B, it is equals to probability A times probability B. So therefore, A and B are independent. Okay, A and B are independent. Okay, that's using the second formula to test it. Okay, using the second formula to test it. Okay, that's about independent. So independent, you want to state whether they are independent or not. You just need to use one of those two formulas. Okay, which information you can get, you just use which one. Normally it's the second one. Okay, normally it's the second one. For example, the question I give you here is using the second formula. If you use the first one, it's not really likely to work it out. Okay, it's not. A intersects B, give you A times B, that's easier. Okay, any other questions? Okay, if no, then we finish up this exercise. I'll give you some homework to do during the weekend.